Welcome back to the channel. Today we're diving into one of the most exciting frontiers in tech, AI-powered humanoid robots. We're going to break down China's new dancing robot that's gone viral, compare it with the three main competitors driving the global humanoid race, and tackle the big question: when will these robots actually do practical tasks in your home? Let's jump in. Let's start with the headline grabber: China's new dancing robot. What's real, what's hyped, and what does it actually mean? This machine isn't just moving to a beat. It's coordinating full-body choreography, synchronized limb control, dynamic balance, and smooth, human-like transitions. Under the hood, it's blending a whole-body motion controller that keeps the center of mass on track, high-torque back-drivable actuators that allow quick pivots and soft landings, and learned policies, either from motion capture imitation or reinforcement learning, that help it hold the routine together even when surfaces or timing change slightly. So why does dancing matter? Because it's a stress test. If a robot can stay upright through rhythmic weight shifts, heel-to-toe transitions, and arm swings that try to throw it off balance, that signals the control stack is maturing. Agility like this is the foundation for useful manipulation in messy, everyday environments. Now, to really understand where this fits, let's zoom out and look at the landscape, the key competitors shaping the field. First up, Boston Dynamics with Atlas. Atlas set the standard for dynamic mobility, parkour, backflips, and lately, tool use with more human-like joints. Its strengths are world-class locomotion and balance, proven hardware durability under high-impact moves, and a tight integration of model-based control with learned behaviors. The catch is that Atlas has been a research platform, not a household product, while Boston Dynamics focuses commercially on spot and stretch for inspection and logistics. Atlas shows us what's possible, even if it's not the robot you can roll into your living room yet. Next, Tesla's Optimus. Tesla's strategy is scale, automotive-grade supply chains, in-house actuators, and a full-stack AI approach with deep vision and fleet learning experience. Recent demos show improved hand dexterity with tendon-like actuation, end-to-end vision models trained on massive datasets, and rapid iteration from a large engineering team. The upside is compelling cost curves and software velocity. The challenge is the home itself. Unstructured environments are much harder than repetitive factory tasks. Progress is steady, but consistent, unscripted household reliability is still being built. Then there's agility robotics with Digit. Digit is designed for real work in logistics. Bird-like legs, a torso for carrying totes, and a focus on stability and safety rather than human-like shape. Its strengths are a clear go-to-market, moving bins, unloading, and material handling, paired with reliability, serviceability, and partnerships with major logistics players. It might not wow you with dance moves, but it's already delivering repeatable, economically useful work, which is a big advantage for adoption. So how does China's dancing robot stack up against all this? In terms of agility, it's closest to Atlas, suggesting mature hardware and competent control. The real test is what comes next: manipulation. Can it open doors, fold towels, and load a dishwasher under different lighting, around clutter, and amid unpredictable human interference? That's where agility meets everyday utility. Let's talk about what it truly takes to be useful at home. Beyond dancing, a practical home robot needs 5 things. First, robust locomotion on real floors. Homes are full of rugs, cables, toys, pets, thresholds, and slick surfaces. Footstep planning has to anticipate slip, handle heel and toe variability, and recover from surprises gracefully. Second, perception that understands objects and tasks. Recognizing a cup isn't enough. The robot needs to infer that it's fragile, half full, and sitting on a reflective counter. That means 3D scene understanding, semantic mapping, instance tracking over time, and affordance recognition, knowing where to grasp, how to twist, and what not to bump. Third, dexterous manipulation with compliance. Hands should switch between precision and power grips, with tactile sensing and force control to avoid crushing or dropping. Bimanual coordination matters, like holding a pot steady with one hand while scraping with the other. Fourth, long horizon task planning. Real chores are multi-step. Gather tools, clear space, execute, verify, clean up, and adapt if something's missing. The robot needs to plan, monitor, and recover when the plan goes off script. Fifth, safety, reliability, and a smooth user interface. Near kids and pets, it must be fail-safe, gentle contact, sensible collision avoidance, and intuitive control via voice, app, or predictable autonomous routines that never catch you off guard. So where are we today? Locomotion is strong in labs and increasingly robust in semi-structured spaces. Dancing, parkour, and factory walking show clear progress. Perception has jumped ahead with foundation vision models and 3D scene networks, but transparent glassware, reflective surfaces, and cluttered drawers still stump systems. Manipulation is the bottleneck. Folding laundry, mixed-load dishwashers, and tangled cords remain tough. Planning is improving quickly as large language models guide skill libraries, enabling better task breakdowns and error recovery, especially when paired with visual and tactile feedback. Let's set some realistic timelines for home usefulness. Over the next 12 to 24 months, expect narrow, semi-scripted tasks in controlled pilots. Clearing tables, sorting specific items, basic vacuuming via attachments, and simple deliveries within a home. You'll see curated demos and early adopters with structured layouts and cooperative users. In 2 to 4 years, we should see reliable execution of a handful of practical chores. Loading dishwashers with common dishes, tidying surfaces, fetching and carrying, opening doors and cabinets, and simple cooking prep like fetching ingredients or basic cutting under supervision. Costs will begin to drop but remain premium, likely subscription-based or robotics as a service, especially in assisted living and care. In 5 to 7 years, broader autonomy in typical homes becomes realistic. Solid navigation across mixed flooring, safe interaction with pets and kids, competent laundry handling for some clothing types, routine trash collection, and simple meal assistance. Expect an ecosystem of routines. Clean the living room, prepare the breakfast station, reset the kitchen after dinner. And in 8 to 10 years, we should reach general-purpose competence across many household tasks with high reliability, helped by cloud-updated skills, home-tuned foundation models, and tactile-rich hands. Pricing moves toward premium appliance territory, still significant, but accessible to a much larger market. It's worth noting 2 big dependencies. First, safety standards, insurance, and liability frameworks need to evolve alongside the technology. Second, real robustness depends on data. Millions of household interactions to cover the long tail of edge cases. So who's best positioned? If you value dynamic mobility and cutting-edge control, Boston Dynamics remains a North Star, though their home product roadmap is less defined. If you're betting on scale, cost curves, and software velocity, Tesla's Optimus makes a strong case, especially if automotive-grade production and vision learning transfer cleanly into robotics. If you want near-term, practical impact, Agility's Digit stands out, solving logistics jobs now and building the service and safety playbook that will translate to homes later. As for China's new dancing robot, it signals serious investment and rapid iteration. If that agility gets paired with capable hands, stronger vision, and a focused set of home tasks, it could become a major contender quickly, particularly in markets with dense manufacturing ecosystems and strong domestic demand for robotics. Before we wrap, here's what to watch next. First, hands and tactile sensing. Look for delicate manipulation, handling plastic bags, folding towels neatly, and working with transparent glassware. Second, real homes instead of lab sets, messy, lived-in spaces with spontaneous human interaction. Third, tool use, spatulas, vacuums, and other attachments are shortcuts to real utility. And finally, update cadence, frequent software improvements that meaningfully boost performance week over week point to a scalable learning pipeline. To bring it all together, dancing isn't just a party trick. It's a proving ground for the balance and coordination that underwrite real-world usefulness. China's new dancing robot shows how fast this field is moving, while Boston Dynamics, Tesla, and Agility are pushing complementary paths toward practicality. In the next few years, expect robots to take on meaningful chores in controlled scenarios, and over the next decade, watch for a steady march toward reliable, general household help. If you enjoyed this deep dive, hit like, subscribe for more tech breakdowns, and tell me in the comments, which household task do you want a robot to master first? Thanks for watching. Please like, subscribe, and share.